Hey there, look, hey, I've got something for you. Industrial Talk is here for your success. That's what we're all about. And as such, we have a couple of resources that are free. No, I'm not going to spam you. I just want you, industrial professionals, to succeed. That's what's important. That's what the focus is. So the two resources, we have an ebook, which is a collection of solutions provided by industry leaders over my 3,000 conversations I've had in industry. That's one. It's out there. Top of the fold, industrialtalk.com. Top of the fold. Second one is an evaluation tool, a workbook, shall we say, that takes you through a journey that says, is my solution aligned with my customers' challenges? That's all it is. And what you do is you answer these questions. It brings about that insight. And then we provide you with insight, because we're all about marketing and sales. We're all about just bringing in opportunities for you. That's what Industrial Talk is all about. So get it. Industrial Talk, top of the fold, buttons, and I'm not going to spam you. So now let's get on with the conversation.
Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Thank you very much for joining the #1 industrial-related podcast in the universe that celebrates you, industry professionals all around the world. You know it. You're bold, you're brave, you dare greatly, you innovate, you collaborate, you solve problems each and every day. That's why you are making the world a better place. That's why we love you. Love you on Industrial Talk. You are the heroes in this story. We're brought to you by Siemens Smart Infrastructure and Grid Solutions. Go out to Siemens.com. Siemens.com. They have great people, great solutions, great company. Find out more. You will not be disappointed. Go out to Siemens.com. We're broadcasting from DistribuTech on the floor. Dallas, Texas is the location. And I'm telling you, it's bigger, better, stronger, faster. And if you're in the world of utilities, in the world of transmission, in the world of power generation, in the world of all of the stuff that makes that happen, and you're not here, you're missing out. Put this on your calendar. It is a no-brainer. Great people. Speaking of great people, Charlie Murray in the hot seat. The company is Switched Source. Do I know anything about it? Absolutely not. But will we? Yes, we will. Let's get cracking. Hi, Charlie.
Hey, how you doing?
No complaints. None whatsoever. Why would I complain? I don't want to complain. You don't want to listen to me complain. And that's what it's all about. Don't complain. You having a good conference?
I'm having a fantastic conference.
Yeah.
A lot of good people here.
You got a booth?
Yep, we got a booth. It's 2846. Getting a lot of good flow at the booth. Yes.
You got your steps and getting over here.
Oh, yeah. Yeah. Well, this is a good place to get your steps in. You know, it's a big conference. Seen a lot of people move around, actually come and visit all the booths. So it's been great so far.
Yeah, no, I'm all giddy. But again, I'm in the salt mine. And at the farthest end of this complex.
Yes. Yeah, that's
So I'm not going to see much. I hear there's great stuff.
There is.
And I'm having great conversations. But anyway, before we get into the conversation about Switched Source, give us a little background on who you are, Charlie.
Yeah, so I'm an electrical engineer by training. Started my life working in the renewable energy development space. Had a lot of different jobs in that space, working on construction, development of projects. Was a subject matter expert for all things electrical engineering. Was coming out of school at a time when power electronics were getting included more and more in a lot of these different types of generation. So we were seeing power electronics included in wind turbines, the large-scale wind turbines you see driving down the highway, as well as solar projects, solar plants. And so that was kind of my expertise, blended that with some of the power systems expertise, and that was kind of my bailiwick for 7 years, working over on the renewable energy and energy storage development side of the world.
Yes. Well, mad street cred. Thank you very much. I think we can just wrap up the conversation saying, Charlie has street cred. Go reach out to him. All right. We have to. The elephant in the room, switched source. Talk to us about switched source.
Yeah, so kind of towards the end of my tenure working in that renewable energy development role, I was trying to develop a lot of energy storage projects and working with a lot of utilities across the country about how we could deploy energy storage on their systems. And there was something that kept coming up there, which was utilities could use more capacity, either at the transmission level, at the distribution level.
When you say capacity, define capacity.
Capacity is the ability to deliver electrons to end users. So we're talking about residential customers, commercial customers, industrial customers.
Is it like cap banks?
It's something,
or something bigger.
Something bigger. It's not just talking about how a capacitor bank could potentially boost the voltage.
Yep.
And it's about how can we actually get the electrons through the wires, kind of through the pipe to those end customers. And when I heard about that, energy storage was kind of an interesting fit for these utilities, but there were some challenges associated with that. And if you think of an energy storage system, there's typically the battery on the back end of it, and the front end of it is this power electronics gateway that they call an inverter. And what we started to realize as a company was there was this opportunity to have power electronics as a controllable gateway, but instead of sticking a battery behind it, stick a different wire, a different part of the infrastructure that wasn't being used as much as the wire that you're trying to help. And so what we did is we looked at the different architectures of distribution systems, transmission systems, and said, hey, maybe there's a way for us to kind of balance out different load pockets with power electronics. And that was the genesis of the idea of our company was we wanted to build tools for distribution utilities to be able to make the most out of the systems that they have today by leveraging power electronics, because a lot of these power electronics technologies are getting more mature and they can actually be deployed at the voltage levels that distribution utilities really care about. So that was the sort of genesis of our company and kind of where we started all of our products from, was this idea.
For clarification, power electronics, what do you mean by that?
Yeah, so these are devices that can be switched very rapidly at high voltages. They're combinations of semiconductor switches with capacitors, different filters and things like that, so that we can take alternating current electricity. Generate that from DC signals, do different types of transformations, and actually control the flow of electrons through the wires.
And you strategically place these devices in areas that have greater demand?
Yes, and there's sort of these natural features in the way that we think about distribution grids where you can bolt on these devices. So to kind of give you a quick example here, if you look up at your typical power pole, you'll typically see 3 wires across the top of it.
Yep, ABC.
Yes, we use 3-phase power. We like that for big rotating machines. A lot of industrial customers, heavy commercial customers use that power. But connected to that distribution circuit, there's also 1,000 residential homes. And those homes only need single-phase power. And so what utilities did a long time ago is they said, hey, it's cheaper and it's more cost effective for us to tap one of those phases and run it to a load pocket, run it to 100 homes. And then we're going to go to the next phase and we're going to tap that phase and we're going to run it to the next group of homes. And so they try to alternate and maintain some balance on the 3 phases, even though they're feeding lots of single phase customers. And then what naturally happens is there's congestion in that 3-phase portion. It's kind of like a 3-lane highway where you can't change lanes. And so there's different traffic, different times of day, different times of year in each of the lanes. And so what we do as a company is we create this device called the Phase EQ. It connects to those 3 wires or the 3 lanes, and then it just naturally equalizes the traffic. It's dynamically updating and balancing out that loading so that you're making the most of the infrastructure that you have.
See, I like that. How do you determine? Do you work with the utilities and saying, okay, here's one of those congested areas that needs help, and how do you go through that?
There's a lot of markers for what circuits are a good fit for us. A lot of utilities have data on the circuits already where they know what system imbalance looks like right at the feeder head. That's right where the 3-phase enters the substation. And so we can typically use that to say, hey, this is a circuit where we're going to be able to unlock meaningful amounts of capacity for your distribution utility so that you can accommodate more load growth from electric vehicles, or just have an easier time reconfiguring the circuit if a storm rolls through and you want to be able to perform actions to switch in loads and out loads. We're going to make the utility operators' lives easier there.
You get that, do you get the information from a system operator? How do you get that information?
We typically engage with the distribution planners, and so these are folks that are looking at, what are those investments we're going to have to make over the next year, 3 years, 5 years, to make sure that we can deliver quality electricity to folks without overloading our system.
When you deploy these solutions, how quickly can you deploy them? Because hey, over here in this phase, right there.
Yes, so the electrical connection to the system takes a few hours. It's really, really fast to actually get the unit deployed. The long pole in the tent for us right now is, this is a pad-mounted device, and so we have to pour a foundation for it. So that can take anywhere from, a week to a few weeks to cure. But the actual electrical connection goes in a few hours, doesn't require an outage for any customer on the entire circuit, and it's quick, it's safe, helps.
How does it not require? How do you do it hot?
So there's a feeder drop that they'll do down the pole, and they'll leave an open slot for fuses to connect that feeder drop to the main circuit. So they're able to do all of the electrical connections back to our box with dead wires, and then at the last step, what they'll do is they'll put the fuses into those slots.
Slap it.
Yep, connect us right back in. We're a shunt device, so we're in parallel with the grid. There's no electricity that's flowing to a customer downstream of us that has to go through our box the way that like a voltage regulator or something like that might work.
When does forgive me if I get it wrong, how does your device get called? Let's say everything's fine. Oh my gosh, it's not fine. I need that.
Yes. Yeah, so we have this device mostly automated in terms of monitoring what that system balance looks like where it's installed. And so we can measure different things about the electrical grid. We can measure different currents and different voltages, and then exchange these electrons to balance out that traffic. We also agree with the utilities about what system conditions they want us to stay connected in, or if they want us to drop offline. So if there is a tree that lands on a branch and it causes a voltage sag, we can define with the utilities, hey, during these voltage sag type events, if it goes below 80% voltage, we'd like you to drop off the line. That's all something that's programmable inside of our device.
Yeah, that's important if you have some veg management issues and you don't want to. So do you, from that, are you collecting the data? You're collecting that information, and you're sending that data back to the utilities. This is what we got. Do you agree? There's got to be some gold in that knowledge.
Yes, and I think we're still starting to understand that, right? So we've deployed this technology at a number of utilities across the country, and we're starting to get this tremendous amount of data, tens of thousands of hours of data, and it tells us things about what customers' usage is and when this imbalance is showing up over the course of a year. Is it a daily imbalance, a seasonal imbalance, and that can better inform the utility operations too as they're doing some of their long-term planning. We are a dynamic device. The more volatility that's out on the grid, the better we're going to perform. We love to eat up that volatility, but we can also inform some of that longer-term planning. So hopefully these distribution planners can make better informed decisions.
Does your device have? If it's on, off, how does that impact the reliability of that asset?
Yeah, so we like to leave our devices on all the time. Utilities do have the ability to turn them off remotely if they so choose. When the device is online, even if there is some sort of storm-related reconfiguration of the circuit, we can ride through that and we can rebalance the circuit dynamically. So if there is a group of homes that was cut off from power, the utility wants to be able to restore service to that group of customers, but they're not really sure how that is going to land from a phase imbalance perspective with the load that's already on this energized circuit. They can have more confidence that we're going to be able to dynamically rebalance it as it's switched in. And that's one of the key benefits of the device here. Again, it comes back to that dynamic ability to respond. That's where we're really helping out these utilities as they're trying to increase reliability and resiliency of the grid.
Yeah, no, I agree with you 100%. When we start talking about distribution, what voltage do you go up to?
Up to 15,000 volts right now.
15?
Yeah, we're trying to go higher and higher.
Do you think there's some interest in a transmission type of solution?
I think so. I think right now we're seeing that there's a lot of impact we can have at the distribution level, but I would say, maybe a few years down the road.
It's huge. Come on.
Yes.
There's plenty.
Yes.
And you're pretty much, do you have an international Desire.
We're looking
50 cycles.
We're looking international too. Yes, there's lots of places throughout. I would say for the way the electrical system is set up right now, we're seeing there's a lot of similarities between how our electrical system works, how it works in Central and South America, other places with kind of similar population densities. So lots of opportunities there. Okay,
put your future hat on. Where do you see it going? I mean, what the world of utilities and switched source, where do you see it going? What gets you excited?
I think what gets us most excited, we know there's an immediate opportunity for us to kind of unlock this load serving capacity for some of the electrification, adoption of electric vehicles. We think that we have a really big role to play with reliability of the grid and making it easier to reconfigure. And it's going to take, I would say, a decade for us to really reach our potential there. So we're pretty excited about the growth we've got in front of us there.
I like this conversation. That's very cool. That's nuts and bolts right there, baby. How do people get a hold of you, Charlie?
They should go to our website, www.switchedsource.com.
Switched source.
You got it.
Are you out there on LinkedIn?
Yes, check me out on LinkedIn, Charles Murray.
Yeah. They will, because I'll have that link.
Perfect.
Out on Industrial Talk, most definitely.
Thanks for having us.
Because you must. Thank you for being on Industrial Talk. All right, we're going to have all the contact information for Charlie. Here's his card. See, right there. His card. And he's the president. Switched Source. Yeah, reach out to him. Put that on your to-do list. That's important because he's important. And they're doing great stuff. And if you're in the world of distribution and transmission and asset management, you just need to be at DistribuTech. All right, we're brought to you by those wonderful people at Siemens Smart Infrastructure and Grid Software. Sorry, I vapored out on that one. Go to Siemens.com. Find out more. You will not be disappointed by any stretch of the imagination. We're broadcasting from DistribuTech here in Dallas, Texas. Put this on your calendar. You have to. We're going to wrap it up on the other side. Stay tuned.
You're listening to the Industrial Talk Podcast Network.
I love all conversations around distribution, transmission, power generation, utilities. I love it. Big time. DistribuTech was the event, as you can tell. Charles Murray. The company is Switched Source. Go out there. We're talking about microgrids. We're talking about how the industry's changing, whether you like it or not. It is a great industry to get involved with. You get to meet people just like Charles and others and be able to really, it's a renaissance. By the way, I have an ebook out there. Industrial Renaissance is the ebook. So it's all about what's taking place in the world of industry, as well as utilities and the solutions. It's all out there. You go to Industrial Talk. It's above the fold. We also have an evaluation tool as well, a workbook. It's all out there. We want you to succeed. We want you to take advantage of all of this incredible stuff that's happening. We want you to succeed. All right, be bold, be brave, dare greatly. Hang out with Charles, change the world. We're going to have another great conversation shortly, so stay tuned.